In this video, I would like to talk about variables, what they are, and how to create them. So in its most basic form, a variable can be thought of as a box with a name, some type of label, that stores some kind of data. For example, if I wanted to store somebody's age, I would have the age as the variable name, and then it would store some number referring to the person's age. Now, anytime in the program I want to use that age, instead of typing the age by hand, I could use the variable wherever I want in my code. And anytime I want to change this age, I only have to change it in one point at my code. I just have to change the variable, and that change will be reflected across every variable in the program. So variables are very useful for storing information, but numbers are not the only type of information variables can store. You can store integers, right, which are whole numbers. You can store decimals, and then you can store non-number values such as Boolean, which is basically true or false. It stores either true or false, or a character, which is a single letter. So you have different types of ways to store information. Now, Java does not know which way you want to store your information. So you have to specify explicitly what kind of data type you want to store. So over here, we have different data types in Java that we can use. Now, the underlined ones in blue are the most common one we'll be using. So, for example, we have Boolean. Boolean means we're storing true or false. So, for example, if we want to see if someone is legally an adult, we could make a variable, a Boolean variable, that stores true or false. Character stores a single character. So, like the letter A or the symbol %. It can store a single character. And then we have int. Int stores an integer, a whole number, either positive or negative, but cannot store decimals. And then double stores decimals, and it can store regular numbers too. So it can store a much wider range of numbers. Now you can see that there's some other ones like byte, shorts, long, and floats. Now these are just variations on integer and double. For example, byte is the same as integer, stores whole number, but only has a range of negative 128 to 127. And you can see short only has a range from negative 30,000 to 30-something thousand. And these kind of data types were more used in times when memory was a serious problem and a serious consideration. Now we can use integer and double for almost every purpose we have. And long and float are, again, just basically int and double with a different range. Now I want to briefly talk about the character data type, because the way Java stores characters is a little different to what you might expect. It doesn't store the character as is. Instead, it encodes it as a number. It gives it a certain number. And what that number is called the Ascii code. So every character you see on your keyboard, on a common English keyboard, has an Ascii code associated with it. So if we go here, we'll see our Ascii code chart. So in this column, we have some special characters, for example. And then over here, we start to see the more common characters. For example, here we can start seeing our numbers. And we can see, for example, 0 is stored as 48. Or A, as the example we just gave, is equal to 65. And knowing this can be useful for doing a few operations. For example, you can think of your characters as numbers, and that can be useful for some operations. It's just worth noting how characters are stored in Java. So these are our primitive data types, essentially our building blocks for all the variables we're going to be using. And then they help us build up and characterize more things so we can create more complicated interactions. We can store more complicated data in stuff called objects, which we'll get to in a later video. Now we can get into creating our variable. Now our variable has two main parts, the declaration and the initialization. Our declaration is where we create our actual variable, and our initialization is where we give that variable its value. So in our declaration, we first specify our data type using the prefix shown over here. And then we give our variable an identifier name. For example, if I want to create an integer called age, I would first specify the prefix, the data type, which is integer, and then I will specify the name, which I would call age, and then I put a semicolon. And here I just created my variable called age. And then in my initialization, I will give my variable a value. So age equals 18. And then we put a semicolon to indicate the end of that instruction. So here we have our declaration, and here we have our initialization. Now I could combine this into one line as int age equals 18. And instead of having it to do on two lines, I can do it in one line. Every single one of these commands is legal, but I cannot do age equals 18 until after I have declared my variable. First, you need to create the variable before you can use it. Now let's briefly talk about identifiers. So first of all, what is an identifier? Well, an identifier is a name you give to a variable, an object, a class, a method. We'll get into what all of those are in later videos. But it's basically a name you give to something in your program. Something that you have the control to name. So for now, our main identifiers that we've been using so far is to name our programs, our classes, and to name our variables. Well, there are certain rules to naming your identifiers. You can only use letters, numbers, the $, and the underscore. You cannot use spaces, you cannot use special characters unless it is the $, or underscore. So you're limited to those characters. It can be capital or lowercase, it doesn't matter. Even though you could use numbers, the second thing is you cannot start with a number. So you can have num2 as a perfectly fine variable name, but 2num is not a valid identifier name because it starts with a number. And then it cannot have spaces, just to clarify on the characters that you are allowed to use. You cannot use spaces. And then the last rule is it cannot be a reserved word. Reserved words are words that Java uses in order to control the flow of the program. So like data types, int, double, the thing that we use for primitive data types. You cannot use those as an identifier name. You cannot use words like class, public, if, for, so on and so forth. And here's a full list of the reserved words. These are words you use to actually program. So it doesn't make sense to have them as a variable name. And then the last thing to mention is identifiers are case sensitive, meaning that the identifier number, all lowercase, number with the capital first letter, and number, which is all capital, are treated as three different identifier names, right? It would be very confusing to have three different variables with the same name but different capitalization, but they're still different nonetheless. And you can't have it. They're treated as three separate entities. Now, because of this, because you can name your identifiers however you like, there are some common practices that are used in order to make programming easier to read and to code. So first of all, we have variables such as the ones that we made. They always start with a lowercase letter. All right, so integers, double characters, booleans, we always start them with a lowercase letter to indicate that we're dealing with a variable. And then if we want more than one word, we can't use spaces. So the way we get around that is we capitalize the first word in every new word. So for example, my age, I'll capitalize the A in age. And then this is what we call a camel hump. And then the last common practice for now is that objects and classes start with an uppercase letter, right? So when we're creating our programs and our classes, we start with an uppercase letter. And when we get into objects in a future video, we'll denote that we're dealing with an object by naming it with a capital letter. The reason I'm talking about the terminology of declaration and initialization is because in your program, if you get an error, the error message will use this kind of terminology. For example, it might say you never declared your variable num. That means it was never created. Or it might say your variable y has never been initialized, and that means you never gave it a value. So when your compiler gives you these kind of error messages, you know what it means and how to fix it in your code. Alright, so I have gone and created a variable class. And inside this class, we will create our public static void main. And now we will start creating our variable. So I want to create an age variable, for example. So I'll do int age equals 18. And then let's create a double. So double num equals negative 5.6. Then let's create a character. Character equals, and then to denote a character, you have to put single quotes around that character. So J, for example, we put a semicolon at the end. These single quotes mean we're dealing with a character. And then lastly, I forgot the identifier name. Character letter. And then lastly, we do a Boolean. Boolean is adult equals false, or equals true in this case because our age is 18. Now, variables are great and all, but they're pretty useless unless we're able to print out the information they store. So the way we print out variable information is by simply using a system.out.print statement or println statement, and inside that statement you simply type in the variable name you want to print out. So age, num, letter, and is adult will all print out the data that they have. So if I compile and I run it, we'll see that we get the variables printed out. Now, printing out the variables are great, but if I just print out these numbers, you don't know what these numbers represent. So it would be good to use a string or a piece of text in front of the actual number or information to let us know what kind of information this is. So the way we can do that is we can use system.out.prints and then print line, but that would get tedious really quickly. So what we can do instead is we can do something called concatenation, which is just a fancy word for joining two things together. So for example, I have age. What I can do is I can put quotation marks in front of it. I want to print out some text, right? So this is age, right? And I'll put a semicolon. And then what I do is between the quotation marks, this pair of quotation marks and the variable, I put a plus. So I'm going to print this out plus the age out. This is called concatenation. And I can go as much as I like. And then after the age, I can print out an exclamation mark, for example. And then I can do this with all of them, as long as I have a plus between every two pieces of information. So if I compile and I run this, we'll see that we get the text printed out. And this is a lot more useful for us as programmers and as users. The next thing I wanted to talk about is declaring multiple variables on the same line. For example, let's say I want to create 3 different variables. I wanted to do int age equals int 18, and then I want to create another int for my zip code, for example. So instead of having to go on a separate line and type zip code equals 123, what I can do instead is Since it's the same data type, I can just put a comma after the first variable, type in zip code equals 123, correct? So what I can do is I can declare multiple variables and even initialize them on the same line as long as the variable, as the data type is the same across all of them. And I don't even have to initialize them. For example, I could decide not to initialize the zip code until later on, where I'll say zip code equals 123. I can do that. All right, and I'll compile it and it runs fine. Another thing I can do, which I want to show, is you can change the value after it's been initialized. You can redeclare it multiple times. For example, we over here will print out that the person is 18. But now let's say they've aged a year, so we can do age equals 19. I've reinitialized it, given the variable a new value, and now we can print out that value again using the exact same variable name. If I compile and I run this, we'll see that first the age is 18, then the age is 19. Because originally, I'll delete this, originally our age was 18 when we created it, and then we printed it out as 18, then we changed it to 19, and then printed it out as 19. So our program goes in sequential order. And you can change any type of data type. For example, if age was a double instead, a double, I could change the double and it would work fine. If it was a Boolean, I could change the Boolean from true to false, or a character from A to B. I can do all of that. But one thing to know is you need to make sure that you're storing the correct data type. For example, if this was an integer, an int, I can store 18 just fine, but I can't store 18.9 because 18.9 is a decimal, and integers aren't meant to store decimals. One last thing I want to talk about is strings. So we've been using strings, which are the text, in our system.out.print statements. But we can also make them variables, sort of. Now, if you notice when we were talking about our primitive data type, string wasn't one of them. That's because string isn't a primitive data type. You can think of a string as just a list of characters. That's really what it is. And string is not technically what you consider a variable, it's what you call an object. But we'll get into that discussion in another video. But I wanted to mention string because we do use strings quite often. And the way we declare a string is the same way we would declare a variable. So we put the data type, which is string, and then we give our identifier name, which is str, equals, and then we give our string its value, Java, for example. And then this stores our string. And to print it out, we do our system.out.print, and we simply print out the same way we print out a variable. We just put the string in here. So practice initializing and declaring variables of different data types. Get yourself familiar with how to create them and use them and print them out using concatenation and all of that. So something you can do is you can create a variable, for example, an integer like we did here, and then print out the value, and then change the value and print it out again, and do it as many times as you want. Get yourself familiar with how to create variables, how to manipulate them, and what the different data types are. Thank you for watching, and I'll see you in the next video.